everybody, and welcome to this month's Codebase. I'm your host Juhis, and Codebase is a developer community show once a month live here on YouTube. I started Codebase a couple of months ago because I wanted to get something that back in the conference times when we were able to meet each other face to face. I always loved the more informal, all-way track discussions. So less about well-rehearsed and prepared presentations, and more about great discussions with interesting developers. And that's how Codebase got started. Each month, I invite somebody who knows something that I don't. And for 90 minutes, we talk about technology, something that they are really passionate about, a new, maybe a language, a library, or way of building things in the world of computers, and especially in the internet. During the day, I work as a developer advocate at a company called Futurist, and during the night, I build different kind of developer communities, Codebase being one of them, and being the newest kind of part of the community efforts, especially during these times when everybody's still sitting at home alone. So this is an open attempt to bring together all the different communities across the technology boundaries to learn from each other and to meet each other. So if you're watching and you're on the chat, feel free to say hi. Always happy to hear who is joining, where you're joining from, and how your Tuesday has been so far. Today, we're gonna talk about web components, and I'm super happy to have Matias as my guest. So let's bring Matias in. Hey
Hello.
Matias, how you doing?
Hello, I'm doing fine. After getting over the first nervous minutes of the show, it's starting to look a lot better right now, and I'm really happy I can come here and share the joy of web components with all of your viewers here.
Awesome. It is super great to have you. So Matias is a software engineer, web component enthusiast, esports fanboy, and open source lover. So if we start from the least technical of this, let's start from the esports. What kind of esports do you like to follow or play?
Well, the more active ones I watch are StarCraft 2 and some StarCraft 1, 2 also. Those are some esports I've watched for, I don't know, like 6-7 years already, and I've grown quite fond of the scene because it's a 1 versus 1 game, so it's a more simpler than the more popular esports nowadays. And the second one I usually want to watch is Super Smash Brothers, but well, I tried to compete in the local events in Super Smash Brothers, but that didn't go quite well. So I've been just sticking to commentating and watching the esports more so on the backside.
Yeah, I'm similar in a way that like I love to watch. I mostly don't watch so much of the kind of esports side. I'm a big fan of speedrunning. That's kind of my niche in the related fields. And every now and then I try to do it, but it's one of those things you need to do quite a lot to get good enough to really kind of to really enjoy it, I think. At me,
Yeah, I don't
there's
think,
never enough time.
yeah, I don't think you can like be an active open source contributor and a esports player at the same time. Like those two are things that take just way too much time.
Yeah. So how about then with the technology? Tell a little bit about your background. How did you, well, first of all, kind of what you do now, and how did you get there?
Well, I started programming in 2015. I kind of got into the training program by accident. I was actually first going to study sales and marketing, but then I had a sudden change of heart, and I was like, I don't know, IT looks cool, like programming looks cool, and I just started the program in Turku in 2015, and I've been working on it half-time / full-time from 2016. So I got into the job scene quite early on. And nowadays I'm working in a small office with a old classmate of mine, and we're trying to run a small consultancy working with technologies like web components, Java, C# and such. And for web components, I got introduced into web components in, I think, late 2018. So it's not that far, but it's quite a few years ago already. So I've been looking at, and I've seen a lot of the evolution of web components under those 3 years.
So we're gonna do some live coding later today, but what are the things that really draws you into web components? Why do you enjoy them so much that it's kind of become your niche focus area?
I think the first thing that comes to mind is I've always been the kind of guy who wants to, like, there's a good saying in Finland, it's like minä itse. So like I want to do it, I want to build it myself, and I don't want to like rely on other libraries or stuff. And web components was introduced to me as a, like, do you not want to use libraries? There is a way. And that kind of drove me into that path. And well, nowadays I use a lot more libraries to help me because I need to get the job done, but it's still a passion of mine to create stuff only using the platform that we have provided and not the libraries that other people have developed. So I think that is like the biggest factor for me wanting to use web components instead of anything else.
Like you said, then sometimes you use things to kind of get things done, and sometimes web components with the kind of internal desire to build things from scratch. How do you balance that as a developer and engineer?
Well, it's actually quite difficult because a lot of the time I'm like trying to pitch an idea and I'm like, we could just make this ourselves. Like it's not that big of a deal. It's just a few weeks of programming and then somebody just shows me that there is already a solution for it. So a lot of the time it's somebody else just telling me like, this is dumb. But also it's that I've done it from the grassroots so many times that I know I can almost calculate how much of a burden something is going to be, and then I just like think to myself, do I want to go through this again? Do I want it to actually work? And then I balance these two things out and usually end up with a nice middle ground.
Yeah, that sounds really good. For everybody joining the stream, feel free to ask questions at any point in the chat. We will then bring some of those up on the stream and discuss those. So if there's something you've always wanted to know about web components or web development, now is a great time to ask. This is a really good opportunity as we have Matias joining for the stream, and I'm personally really excited with this topic because I've been working with things like React and Vue, but I haven't really kind of gone into web components on its kind of purest form. So for me, I'm also excited to learn what this is all about and how to kind of bridge that world from kind of more, I don't think more advanced is the right term, but kind of like a different approach is probably what the like React and Vue libraries do in comparison to web components.
Yeah, a different approach is a really nice way to put it, because like I wouldn't be comparing the actual complexity of these solutions between like React and Vue and something like web components and Lit, because everybody just does it in a different way, and like each of the ways has a use case, so they wouldn't be so popular if they wouldn't be useful in some points.
That's one of the things that really excites me about technology, is that in a lot of fields you have these like standards and you have really kind of established ways of doing things. But then in technology, for the better or the worst, you get the like creative freedom to do things the way that you believe is the best way. And that's kind of the velocity of the evolution of the some of them become popular. And as I've been following web components a little bit, it seems that it's been really picking up. Rather like lately. It's been there for quite a while, but I think in the last maybe year or two, it's been really popping up more and more. Do you see
really
the same?
has. Yeah, it really has. Like if you look behind in time, like for example, 5 years ago, you can find some web component repositories, but those are plain HTML files with something janky, some janky JavaScript just shoved in there. It's more of a proof of concept when you compare it to the APIs we have today. And as of, I think it was last year or this year, when we dropped IE 11, web components have been just absolutely booming because there's practically no platform that doesn't support web components. So it's like we've given the green light to do anything with them, and the standards have been going forward in that field a lot during the last 3 years. Like even in the time I've written web components, they've changed a lot, and also the people behind a lot of the popular libraries have been really adamant on providing tooling, providing documentation, and providing guides to creating web components.
Yeah. So, for the viewers who are not familiar with web components, and also me, can you give a really quick introduction on just kind of like what web components are before we jump into the code? Why do they exist? What do they do? And who is using them?
Yeah, so like the idea of web components is quite simple. It's like when you look at the basic HTML tags you have when you're creating a page, there's the divs, spans, p tags, h1 tags, and everything. You might be thinking at some point like, I wish there was a HTML tag for this functionality. Well, web components are an API which lets you basically do that. You are creating custom HTML tags which have custom code running inside them, which you have written or somebody else has written, and they are executed in the same way as normal HTML is, parsed in the same way as normal HTML is. There's a few extra steps, of course, but in the most simplest of forms, they're like just custom HTML tags you're able to create. And when you look at the browsers, for example, the input elements are basically web components in of themselves. Anybody who has done any kind of a form in HTML, you know that when you make an input component and you give it a type checkbox, it changes completely. There's a value field that gives you a value, but there's also a checked field at that point, and it changes in the appearance and everything. So basically, the input field functions as a web component already. So that's after extending the APIs and giving the developers more freedom, we are now able to create our own HTML tags we can control, create, and extend upon. So I think that's like the most simplest way I can explain web components. It's a vast swamp of information if we go deep enough, but that's like the most simplest way I can explain them.
Yeah, I think that's a really good starting point, and we'll see some examples soon.
Yeah.
So you mentioned that now the browser support is really good.
Yeah.
Are they supported natively, or do you need to have some kind of like a build step at some point? How does that function?
They're completely supported natively. So today we are writing code which can be written, and it's straight up read by the browser's JavaScript engine, and it just works in the browser without a single build step or any transpiler or compiling of the JavaScript code. So you can write it once, and you can just deploy the written code, and it should work on any modern browser. And that's what makes it so cool, because you can basically implement web components anywhere you have a JavaScript interpreter and a browser window. So that means you can make web components in CodePen, CodeSandbox, or any of the other platforms.
That's cool. So let's talk a little bit about tooling. I know that you're building like a developer tool, kind of an extension for a browser. But in general, what does the tooling look like, and then also like what is it that you're building?
Yeah, so well, going back to when I started with web components, I actually took a look at a project we started in 2018, I think it was, or 2019, and after staring at it a little bit and crying to myself a bit because the code was so bad, I was looking at the tooling back then, and I came to realize how far we've come with the tooling, because previously, when you wanted to use web components, you had polyfills, so you could support all the browsers, and you also were building your project with Webpack. And anybody who has touched Webpack knows it's a burden, to say the least. And it's come a long way, and a big thanks to it goes to a organization called OpenWC. If you want to maybe share my screen a little bit, I will show the homepage of them. OpenWC stands for Open Web Component, and it's a group of people who just love making web components and love making tooling for web components. OpenWC made me fall in love with web components. OpenWC provided the tooling that made me be able to use the web components in the way I use them today. And if we look at the headings in the guides, there's already a going buildless section. So when developing web components, going buildless and having the minimal tooling is like the gold standard, and that's what we aim towards. And when it comes to tooling that I use daily, I mostly just use a dev server, which just serves my HTML files, resolves my JavaScript dependencies, and basically refreshes the web page on code changes. So that's the only tooling I use. But there's also other tooling they provide. For example, they have examples for rollup. There's a, let's see, I didn't study the page nicely enough, but there's a huge tooling for rollup to pack your web components into a more concise form when you're publishing them, because even though we're not required building when we're doing web components, when you're publishing it to the World Wide Web, you might want to still bundle it into a smaller bundle, so you have your dependencies in one place, at least until we have import maps, but that's a story for a different day. And also there's another organization which makes, let's see, I'm not quite sure which organization they are. Yes, here. So Modern Web Dev is a organization that does a lot of work on web components also. And Modern Web Dev actually consists of some of the same people who had worked in OpenWC. And the founder of OpenWC is a co-founder in Modern Web. So when you're developing web components, almost all of the tooling you should be using should be from these guys, because they just make awesome tooling around web components, and they develop with web components on a daily basis, so they know what's best for you. So I would say the tooling is quite good, and I would say that you should be able to develop with minimal tooling necessary quite easily without any kind of configuration or fighting with your configurations.
Yeah, I really like the sound of that. I think like the modern web development sometimes feels super complex with all the like build tools and package bundling and everything that you need.
Yeah.
Like, when I started coding, it was just like you write HTML and JavaScript and like PHP and you FTP them to the server, and sometimes I miss those days.
Yeah, those were the simpler days. You could just slap a jQuery on anything and it just works, and you would have a image carousel in 2 minutes. Nowadays you have to build a React project for that.
Yeah. So then, about the tool that you're building right now, we can take a quick demo at the end once we have seen a little bit of what the web component give a really quick teaser on what you've been doing?
Yeah, so basically, I've been working with web components for a couple of years already, and I've been kind of wondering like why is there no browser extension tooling for web components, at least any of tooling I know. And I worked with React before, and I know that React has a React DevTools extension for Chrome and Firefox. So I was wondering to myself, like, why don't we have a web component DevTools, like a carbon copy of that? And I searched through the web, and I was like, well, nobody has done this yet, and could it be that it's just impossible? And I talked with some of the folks from OpenWC and Lit, and nobody seemed to know if there's any projects on that field. And I just started fiddling around with the Chrome extension code one day and created a small proof of concept of DevTools for web components, and I shared it on Twitter, and it got a lot of traction, like more than any of my tweets before. And I just have been keeping up with it, and after a month or so of development, I'm closing in on releasing the 1.0 version of the DevTools. And what it aims to do is perfect the web component development process to become even better than it has already become, by providing you with the same kind of development tools you have, for example, from your Elements window in your browser. So you could select a element and change a attribute of that element, see how it reacts to it, maybe click a checkbox or something and see how it reacts to those changes. And well, I hope we have time to show a small demo at the end, as that will maybe explain more on how it will work and how it will actually enhance your development experience.
Yeah. So now that we know a little bit about what the web components are, maybe we should take a look at the code. Let's see how to actually build those things. So
yeah,
let me bring up the screen, and please let us know in the chat if the font size is good enough. We can make it bigger if needed, but let's start with what we have now, and if nobody complains, then we'll stick to that.
Yeah, for sure. So we'll be starting from a fresh directory, so we won't be having any files to prove that web components are a thing you can build on the browser without any kind of bundling or anything. And well, if we start our editor and create a simple index.html file, so we have something to serve, like the only HTML we need for the site is basically this. And also we need to, of course, import a JavaScript module. But first, we are going to be creating a small extending web component. So there's two kinds of web components. There's those web components which extend pre-existing HTML elements, and there's also custom web components which extend the HTML element base class and provide a custom functionality to them. So first, we are going to be creating a simple extension to the native button HTML tag. So we'll start from the most classic of JavaScript examples, which is a counter. So we have a button, and we have a imported JavaScript module. Well, next we want to, of course, create the JavaScript module, and let's open it up. And we can make sure it works by using the trustful console log. And I was talking about the tooling before. What makes the Open Web Components tooling so good is that it doesn't even require you to have a npm project, so a package JSON in your project. So if we look at the folder, it only has the index.html and a counter.js. I'm on a Linux system, which means I can create nice aliases for myself. And I have a alias for dev server, which uses npx, which is a command for npm to download a library and execute it immediately in the current location. So I can just execute it with one command. I can execute the dev server with no kinds of configuration files. The only configuration I have is within the command. And I have only two commands. It's node resolve, which is not even necessary here. It would just give us the dependencies of the project packed up if we needed them. And watch, which makes the Chrome browser window refresh when we make changes to the code. So if we run the command, it's already cached on my system, which means it'll run in a few seconds now. And we see that if we refresh the page, we have the button there. And from now on, we also see the console log here. I'll try to zoom it in a bit. And from now on, every time I make a change to the code, it will update immediately, and it's super fast. It's like faster than any of the other build tooling I've ever used because, well, it doesn't need to build. It just serves the files again and refreshes the page. And at some points, it doesn't even need to refresh the whole page. But that's for more special occasions. And when we are creating our web components are almost always class-based, at least beneath the surface. There's frameworks to make web components with hooks, but we're not going there. So we wanted to make a counter button. So we just start with a class called counter button, and we'll be extending a native browser class named HTML button element, which is, if you look at the documentation, it's just the properties and methods that a regular button HTML tag provides us. And then that's the first part of creating a web component at any point. So you just create a simple class, and then you need to utilize the first API that creates web components, which is the custom elements API. So in the window object, we have a nice hefty class named custom elements. And in that class, we have four methods. We have define, get, upgrade, and when defined. So we want to define a new custom element, and we will name it counter button, and we will tell it that the counter button custom element uses the class counter button. And since we're extending the HTML button tag here, we will give it a third argument, which is extends, and we will just tell it that it extends the button element of the HTML system. And already we have a custom element defined. So if we in the browser window go custom elements get counter / button, we will get the code that we have in our view here. And now we want to make sure that the button works. So we of course use our trusty console log. I'm working. And well, everybody who has written JavaScript knows what a constructor is. So it's when the element is created. And if we're looking at the page now, we don't see a console log. And that is because we haven't implemented the element yet. When we're creating a extended element, we cannot just go ahead and use counter button in this way that we would expect it to work. Like when we're extending HTML elements, we use a keyword called is. So we grab a element from our page and call is and tell it, okay, you are now a counter button. And as you see now, the console log has appeared on our web page. So we have already made click me into a custom button that has arbitrary code we have written running on it. And next up, if we wanted to make it an actual counter, we would of course want to keep track when it's clicked. So we want to have a count variable in the class, and we want to add a click event handler onto the class. And every time it's clicked, we want to increment the count by 1. And I can also console log I've been clicked. This count times, and since we have the wrong yes, and now if we click on the element, we see already that it's executing the event listeners on it. So we can easily attach event listeners without having to write JavaScript on the HTML page. So for these use cases, it could be, for example, if you're modifying a WordPress page, you might not want to be going into the JavaScript side of the WordPress page, especially if you're not a JavaScript developer. This gives you so much custom functionality for different kinds of elements on your page, and it gives you so much freedom. If we wanted, we could even we could even add some elements on our page. So we could add a actual counter that gives us the current count on the screen without printing it into the console. And we could, let's see, I've been clicked this count times, and we will be putting this inside a span. This is due to us being required to actually get a hold of the content inside the span later on. And after that, we want to find the actual counter field. And we can find it easily by just query selecting the span element from inside it. And then in here, we just want to update the text inside of that element when we need to. And I have type checking on, so it's telling me it's not plausible to add a number to a string, but we'll make it work because JavaScript works in magical ways. And as we can see, there's no element on the button yet, or a text on the button yet, and that is clearly because we haven't appended it onto the web page. And we can easily do that by getting the parent node of this element and inserting a element before our element. And if we do this, we have a text that is appended onto the page without us even adding it into the index.html. If we look at it in our inspector, we can see it's a p tag before the button tag. And if we click on it, we can see that it immediately updates the values without us having to do any kind of framework shenanigans or any kind of rendering or anything.
Yeah, I have to say I'm already a big fan of that super fast auto reload. Like that is amazing.
Yeah, it's just absolutely amazing, and it keeps the speed even on larger projects. So I have never had to wait even half a second for the project to serve itself onto the browser. So it's super fast every time, sometimes even too fast. That's why I usually like to work so that I have code on one workspace and the monitor on another, so I don't see it flashing all the time because it's just does it so fast.
Yeah. So then the first thing that I noticed coming from like React and Vue background is that you kind of need to manually update the things, right? So there's no kind of like automated data binding. Is that correct? Yeah.
Yeah. In custom elements, like in the bare bones level, there is no automatic data binding. When we go to the custom elements next, we will see how we could maybe implement that ourselves. But yeah, there's no, like, you cannot just have a this.count is set state 0, which would be something you would do in React. You would have a count and a set count. Like, this is how you would do it in React, but in just plain old web components, you really have to do everything manually. So you have to come up with your own way of updating your elements. We're going to be going into a small helper library later on in this live coding session, which provides a lot of functionality, including the data bindings, which we talked about.
Yeah. So in this case, you were extending an existing button.
Yeah.
What kind of things do you get? Kind of like, why would somebody extend a button rather than creating their own? What are the benefits on like taking advantage of the existing elements?
Yeah, that's actually a question I get a lot. But it's a simple thing. Like, you don't need to go around and you don't have to invent the wheel again. So that's like the most basic form. So I saw your talk with Fotis. I can't remember names. I'm so bad, but it was about accessibility, and that's a big thing in web components also. And if you are extending a button, that means you are getting all the sweet benefits of a button. For example, if you have a button, you are able to click it with your keyboard by just tabbing into it and then pressing space. So you have all the built-in functionality of HTML elements already at your fingertips before even writing any functionality for it. Also, if you just start off bare, there might be some other values you are not getting instantly and some other feature of the browser you're not getting instantly. For example, if you're writing a input element and you're making it from a div and you just update the value of the div, it's kind of a counter pattern when you think about how the browser wants to think about the input, because browser is searching especially for a input element and not a div with a input type true or something like that. So just extending the element instead of making it into a custom element, or a custom element in a shadow root, to go even deeper, it's just that you get all the bells and whistles from the package with it, which usually help with accessibility and a lot of more things with the web page.
Yeah, awesome. Another question that I have is when the event listener runs, does it only update that part of the DOM, or does it do some kind of smart sub refresh of the DOM? I don't know what sub rendering, or does it kind of rewrite everything?
As we can see, it doesn't fully re-render the whole span. We can see from Chrome has a awesome tooling for this. Like just the elements window on Chrome shows with a flash what parts of the DOM updated when you do something. And here you can see that the number of inside the span tag updated, but also that the span tag itself updated. So it doesn't rebind the whole span tag, so it doesn't create a new span and make the browser calculate all the fittings and everything. It just updates the content inside it. It has to do some small calculations like, do I fit into this space or do I need to extend, and like that. But those are things it would have to do anyways. So in this example, it's quite minimal how much it does update, and I don't think you can get lower than this without having a powerful framework and some tags to work with it.
Yeah, I really like the simplicity. And I want to remind the chat, if anybody has any questions at any point from anything that you see, feel free to ask in the chat, and we will answer them to our best ability. Or probably Matias will answer, and I will make funny remarks.
Yes, we can just smile and nod if there's a difficult question. But moving on, we are next going to be looking at if we wanted to make a fully custom element on our page. So we'll be just creating a new element, so a new JavaScript file, and the element we're making here is, well, we could actually, let's move on outside of this. Let's see, and maybe start the actual project I wanted to showcase, because the example just works way better with that one. So we're going to be creating a nice Nintendo themed web component over here. And by the way, one of the companies that actually has implemented web components on their pages is Nintendo. So a lot of big companies are already utilizing web components. And I think as I'm just initializing the project here, but I think one of the big things about web components is that you can, since they don't require a framework or they don't require any kind of special tooling, it's a perfect transition tool for companies to transition technologies to another technology. For example, there's a lot of companies that might be moving on to web components by first introducing a few of their design system elements in web components and just replacing the existing, for example, React, Preact, Vue components on their page with a web components, because the interoperability is built in because web components are part of the actual browser API, so they don't require any kind of extra libraries to be slapped on there. So they're a perfect transition tool for almost any company to transition from maybe a bit older frameworks or libraries, or even from modern ones.
Yeah.
And
while Matias is setting that up, I want to just kind of briefly mention that we are both really big Pokemon fans, that we've been both playing the Pokemon TCG, so this is really kind of on brand for both of us to do something Pokemon related.
yeah,
and I'm super happy that Matias chose the example to be about Pokemon.
Yeah, and especially Pokemon cards, because Pokemon cards are the only medium of Pokemon I have time to or have current interest on, like using. Let's see. So we have our HTML tag again. So of course, when you're building for production, you have a lot of meta tags and everything in these. But this is just to show that I'm not doing anything under the hood that you are not seeing. I'm creating the HTML tags from scratch, and I'm also creating the JavaScript tags from scratch. So our current setup is just a Pokemon card web component. You can recognize it from the dash. The dash is a required in the web component name. So you cannot name a web component without a dash in its name. It's just so it doesn't confuse itself with a regular HTML element. And
so what happens if you run the website now before you have actually built the web component?
Yeah, I was about to do that. Next, I'll actually, let's see, I'll type dev server. I'll just run it through that because it doesn't really matter. I just installed it as a dependency, so we know. So we have no problem here. We have a Pokemon card web component. We have no errors in the console because the HTML parser is not allowed to throw errors. So the HTML parser is like, yeah, this is valid HTML, yeah. So it doesn't like, there's nothing wrong with the HTML. It's just that there's no functionality built into it. So if we look at it in the editor, it's just a sizeless, functionless component that we have on our page. It doesn't even have any styles. Like even a body has some built-in styles. The web component doesn't have any style. It's like
Does that also mean that it doesn't have any bugs? Do we have to introduce those ourselves?
Yeah, we have to introduce all the bugs ourselves, which is the bad part in this. It's just cumbersome that you have to introduce all the bugs yourself. And as we are working with the Pokemon API, I created a small tool to help me with getting the cards from the API. It's just a small 13-line JavaScript function that gets the Pokemon cards from the public API. No API keys required or anything. But that isn't the main point here. The main point here is making the actual Pokemon card. So we have our index.html here. And
could we maybe really quickly, before we go into that, could you show in the browser to those who are not familiar with the game, what is a Pokemon card? To maybe give them a bit more kind of visual understanding of what we're building.
Yeah. So just a normal Pokemon card is just a cardboard card that has a Pokemon on it, and we're not actually going to be making all the parts of the card ourselves. We're just going to be using a API to get the image of the Pokemon, and we're going to be making a small input form to be able to query different Pokemons from the site. But this is a regular Pokemon card, which we're going to be fetching from the site, from the API. And to start the web component, we are going to do the same setup process we did with the extending component. there's a few different places, few different methods we're going to do. The first thing is that the extends doesn't extend a existing component. It extends just a basic HTML element. An HTML element is a base class that every real HTML element extends. So the HTML button we used before extends from the HTML element. And it just gives us an interface that allows us to make functional web components with our setup. And if we are going to look into the browser now, we can see that our code, we have the dev server is down. I accidentally put it down. So let's see here. So as we can see here, now our Pokemon card is still without any kind of a body. But if we console log here, we can see immediately that our Pokemon card is registered. So that's a good thing. That's a good indicator that we have created a successful web component. And now we're going into the second part of the Web Components API. That is encapsulation. So what encapsulation means is that we can separate styling from our parent page and our component. So we can have custom styles on our page without affecting the styles of the web page itself. And also we can do anything on our component without inheriting the styles from our parent page. So that's the first thing that a lot of people who get into web components find maybe a little bit cumbersome, is that if you want to use the shadow DOM, which means that you want to have a separate shadow root inside your component, which allows us to encapsulate the styles, you cannot use a CSS framework, for example, Bootstrap, because we are working with elements that are not accessible by the regular CSS in the top level. There's some tooling that allows us to do that. And also there's web components that do not use the shadow DOM, but that's going to limit them with the functionality itself. So we could just omit this row of code, and we could just write this .inner HTML equals foo. And if we do this, we will see the foo on the page. And if we look at the DOM tree, it's a child of the Pokemon card. But in this situation, if we had content inside here, we had a p element with Pokemon inside here, it would not show up. Because if you are not using the Shadow DOM API, you are not going to have access to elements which have child components. And that's quite a limiting factor if you think about the whole way you write HTML. You have for example, a list, you have a UL tag and you have a lot of lit tags under it. So you wouldn't be able to do that, and you would have to work around it in another way. But if we do attach the Shadow DOM here, we see that nothing gets appended on the screen. But if we, instead of modifying the actual inner HTML of the tag, we modify the shadow roots inner HTML, we see that the foo has appeared on the page. And here, the next thing is one of the coolest things in web components, and that's slots. So in React, you can make nested components. You can make room for them, and you can just you can have like props.children, and everything you put inside the component appears inside the component where you want them to be. Well, slots are a HTML tag that does the same, but it does it for the elements in the light DOM. So in web components, there's two DOMs. So DOM is the document object model, so basically the HTML on the web page. There's light DOM, which means anything that can be touched by the HTML and head tag. So everything that you normally write on the web. But there's also the shadow DOM, the shadow way of doing it. And that is the encapsulation we get. And in the shadow DOM, we have the content we just appended into it. And when we have a slot, the slot takes all the content that is inside the light DOM of the element, in this case the Pokemon, and puts it inside the slot. So we can see it's referencing the value, this value, and putting it here. And the slots don't really care how much content you have inside them. They will just append them in order. But the cool thing about slots is you can also name them. Were you about to ask something before we go into named slots?
Yeah, I was about to ask and kind of make an assumption that you can also put other web components inside the slots.
Yes.
So you can basically, since they are just basically HTML elements, you can just use them anywhere you would use otherwise the regular ones.
Absolutely. Like that's the great part about web components. You can use them like you would use a regular component. So you could have a web component inside of a web component and it would work fine because it's just a HTML tag and nothing else. Doesn't need a rendering function or anything. And with the named slots, we can, for example, name a slot header. And if we wanted some content above the full text, we could name it a header. And we could add content here, a p tag, which says I am at the top. And as we can see, it's not at the top because the foo is at the top. But if we tell it to, instead of going into the default slot, go into the header slot, we see that it goes inside the header slot. And if we go into the shadow DOM, we can see that slot name header, there's a p tag inside this. And the cool thing about these is they don't really care about HTML composition, so they don't care where they are inside the light DOM. So they could even be at the bottom, and they would still appear in the header slot. So you have the freedom of writing any sort of HTML inside of the inside of the light DOM, and it will just organize itself with the slots.
Does it also then move like within the DOM to the correct spot? Because like right now it shows the slot, but then it shows the elements at the end.
Yeah.
So for example, if you're using like a screen reader or something, in which order will it see the elements when using slots? And especially like name slots.
It sees them in the order you have them in the light DOM. So, for example, if we go on the page and just do a regular query selector, the first is here. And let's see if we choose all. The first one is there. The second one is there. The third one is there. And the fourth one is there. So it sees them in the same order you put them into the light DOM. So it just basically reflects them onto the shadow DOM in the right position. But for screen readers and such, it will have them in the same order you have them inside the children. But this can also be modified with tab index and such. And let's go forwards. I try to see how much time I have left. There's so much to talk about still. We will then go into the last one of the three APIs that make up web components, and that's templates. So what makes web components so fast is that the browser has to evaluate the HTML tags only once. And how does it do that? It's with a technology called templates. So there's a HTML tag called template. This is a tag that some maybe more old school developers might remember. It's a tag that allows you to put content on the page, but it doesn't get evaluated at runtime, or it doesn't get evaluated when the DOM tree is parsed. And we can put any content inside of here, and we have created a element with template, and in our HTML on our Pokemon, we can put any content in here and it doesn't appear anywhere on the page. It does appear when we decide to put it inside of our shadow root. And we're not going to be using inner HTML because it's so expensive. instead we're just going to be appending a child. But anybody who has used this function knows that it takes a HTML document element, so you would have to use a query set or something to find the element on the page. But we can also, with template, we can take the contents of the template and we can just clone it. So the browser has already evaluated the HTML here and said it's like, yeah, it's valid, it's all right, just you can use this. And then later on we can just clone it, and it doesn't have to evaluate it again because we have made a clone of it, and it just speeds up the process a lot. And we're just using a true parameter in the clone to make it a deep clone. So that's not anything relevant really. But when developing vanilla web components, this is usually the way you do the content. So you don't do it inside the constructor. You have a different template here, and you define the template's inner HTML here, and you just clone it in your constructor so it's ready as soon as possible. And next, going into the actual encapsulation side, we have a p tag inside of the component, and we have a p tag outside of the component. If we write any style into the light DOM that targets any components that are inside of the shadow root, we see that it's not applied to the element. There's a few CSS properties that get applied through Shadow DOM, but it's only like I think it's like fonts and stuff related to fonts, really. And this is the kind of encapsulation we want. So if we wanted to style something inside of our components without having to have a class Pokemon card, please do not clash. So we don't want to clash it with any other component's class name. We would have to go through a cumbersome journey. But with the encapsulation, we can just style the tag here, and it's going to be in the color we want it to be in. So this is one of the big superpowers of web components. You can have encapsulated styles, encapsulated JavaScript, and encapsulated content without affecting the parent. So it's a perfect tool for anything that runs inside a web page with a lot of other stuff. For example, a module-based system. Like if you had a page with different modules from different providers, if everyone just packed them into a encapsulated web component, they would not be able to talk to each other, and they would not be able to affect each other's styles, at least without breaking some browser rules.
Yeah, so it kind of protects it both ways. So when you share a component, you can make sure that it looks the way it's been styled, and also that it doesn't, like when you use a component, it doesn't break what you have.
Yeah. And going forward, so we have time to actually make the component, I'm going to be taking a couple of snippets of code so we get there in time. The first thing is a host tag. So with Shadow Root, we get a new custom selector for CSS called :host, and it just affects the web component itself. So the actual HTML tag called Pokemon card. Let's see, actually, there's a display block. So we can immediately we can directly affect the host element of our web component with the host CSS property. So this is different from React, for example, where you have to wrap every element into some kind of a wrapper. It's a div or a form or a span or something. And I think it's really cumbersome when you have to always have the div, and then you see the sites with div going down the stream. It's a lot more declarative just having the Pokemon card and having its contents. Like no brainer. This just a Pokemon card, and you know what it does, and it's not a div class, whatever the compiler or bundler put out. And next up, we're going to be doing the actual Pokemon card into the element. We're going to be starting by creating a ASAC function called render card. So as we talked earlier, you are not able to modify the contents like dynamically. or like it doesn't do it itself. You have to write the logic yourself inside the content, inside the component. And for that, we're going to be creating a image tag. So we want the Pokemon card, and we don't need to give the image tag any kind of a ID or a class, because we know that we're not going to be putting any other image tag inside of our component. So we can easily just have a empty image tag, and we can reference it by const image tag is this.shadowroot.querySelector image. And we also want to make sure we have everything along the way. So we just console log it, so we see that we have this.render is not a function because it's render card. Yeah, so we have the image tag there, and we have the reference, and we don't have to have any IDs or anything polluting the space, because we know that there's only one image tag inside of the Shadow DOM. And next up, we are going to be getting the actual Pokemon image from the API. So we're going to have a card info, which is just a call to our get Pokemon API. Let's import it. And let's give it some parameters. For example, if we wanted to get, well, one of my favorite Pokemons, Psyduck, we would want to go search for the name Psyduck, and I especially like the Detective Pikachu one. So we want to get the card info on that one. And if we log the card info on that one, we get the data array, and it has the info of the card. So all we have to do now is just get the image from the info and append it onto the image tag. And since we have the image tag already referenced in our code, we can just instantly modify our card image property, or source property of the card with the image. Yeah, that's what I was supposed to say. And we want to always get the first card from the card info, so I'm just going to be writing some small boilerplate here. And if I access the image card's link to the Psyduck image, we immediately see that we have the image rendering our screen, because we call the render card in our constructor. But there's a better API callback for this called connected callback. So anybody who has worked with something like React knows that there's a component mount callback that is like, okay, I know now we're in the DOM and we can access stuff in the DOM. Connected callback is basically the grandfather of those callbacks, and it just tells us when we are connected into the DOM and we are okay to go and execute stuff on the DOM. And when we have it in here, we can immediately get rendering cards on our page. But what would be components if there was hard-coded values? Next up, we are going to be getting the value from our attributes. We have a get attribute, which is something that a lot of developers should know, which is something that accesses the attributes of a HTML element. So anything that we have written on the HTML element itself. For example, if you have an input element, you have always the input type text, or whatever you have the input as. The type is the attribute, and text is the value of that attribute. So for the Pokemon card, we wanted a name attribute, and we would say Psyduck here. And when we see the refresh, we see that it's already using the attribute we used. And if we say, for example, Pikachu, we get Detective Pikachu as the card. So it's a really fast way to get dynamic information flowing from our HTML tag onto our JavaScript. We can do the same for example, the set ID. So we could just have a get attribute set. Of course, we could have fallbacks for these, but we don't really need them for this demo. But if we want to do this, we would be able to do it. And I think I know that there's a Psyduck card in this set, so we could find a... Well, there wasn't. Let's see. There's a Psyduck in the base set, at least. And we see that we get the actual Psyduck from the base set. But this is quite cumbersome because it really makes you have to get attribute, and it doesn't really react to anything. If we change the attribute of the page from the page, for example, we go Pokemon/guard and set attribute name is Pikachu, our card doesn't update even though it has the Pikachu in the name. That's when the attribute changed callback comes to play. So there's another callback function in the HTML element that we can use, which is the attribute changed callback, which takes 3 parameters: the name of the attribute that changed, the old value, and the new value of the parameter. We can name the variables, of course, ourselves. But if we do this, we are able to see what changed and when on our component. So nothing changed now. And if we do this, nothing changed anyways. And that is because there is a third API called observed attributes, which is just a list of attributes we need to observe and call the callback on when they change. So if we just list name and set here, we will see that observed, yes. We will see that attribute changed, name, old value was null, and new value is Psyduck. Attribute change set, old value is null, new set is base P. And if we do the update the attribute, we see that it's called again on the Pikachu. And in this callback, we could of course call render card. And if we do this, when we update the attribute, we of course get the card updating with it. So now we basically have a dynamic web component which updates when the attribute value is updated. But there's like a lot of pitfalls that could happen in this kind of systems. For example, we are updating the card 3 times in the render process because we are getting the card data updated all the time. So there's a lot of optimizations you would have to do to this code to have it actually production ready. And as I see we're not too good on time, I'm going to be skipping a bit ahead. And I'm going to be showing how you would do it with a little bit of helper libraries. Well, the first thing I'm going to be showing is the, let's see, there's the, let's see, which one was it? Vanilla element demo. So if we wanted to make it a functional web component ready for publishing, we would maybe want to, for example, reflect the state in properties. So instead of having the attributes only change, we would want to be able to access the Pokemon card class by typing this.Pokemon, this.set, instead of this.get attribute. And in that case, our attribute change callback would look quite different. We have our this, and we will modify the name inside of this class with the new value. And this is a simple hack to make Boolean values work in browsers. So there's a, I will show it with the demo. So if we had the same page here, we would have the card as a large card because in the page we have a large Boolean value set. So if we remove it, we have a small card. So I think everybody has seen Boolean values or Boolean attributes at some point in their career, especially, for example, input type text required. You don't have to tell the input field that it's a required equals true because it's a Boolean value. It's a either it is in the attributes or it's not in the attributes. And if it's typed like this, the HTML parser will set the value as a empty string instead of null. And what this check does is just check the new value. If it's an empty string, we can assume that the attribute exists in the element. And then we can just set it to true, so we have an actual Boolean value instead of a string equaling true. And if it doesn't equal to that, we can use the new value as is, which is most likely a string. Whew, I need to go fast. If there's any questions, just ask ahead. There's so much about web components, and I want to go into the maybe a bit more interesting parts. So I'm trying to go fast over here. But
yeah, we can use the next even 15 minutes still if
all right.
If you have let's try to wrap around the code at 25 past.
Yeah,
and then
for sure.
We can speed run the wrap up part of because I think the code is more interesting than my wrap up. Thanks. So feel free to take a bit extra time.
Yeah, thanks for that. It's always hard, and I almost always go overtime with web components because there's just so much to talk about in the web components, and I don't want to really skim through important parts. But yeah, here we have a similar project structure. Instead of just having the Pokemon card, we have a input form also. It has the Pokemon name, Pokemon set, and a submit button. I will also put it on the screen. So it should look like no Firefox. I don't need you today. Yeah, so it's basically the same page, but here we have also a input field. Juhis, what is your favorite Pokemon?
My favorite is Gengar.
Do you have any sets where Gengar has? Do you remember any sets where Gengar has been?
Don't remember the ID, but one of my favorite cards is from the Short and Sealed promo. So I think it's SWSHB. Maybe.
Let's see. Oh,
Yes,
you were right.
Exactly that one.
Here we are able.
The art.
Yeah, it's. I really like the more cartoony ones that they make at times. Also, it's Pokemon cards are just so much to look at. But getting back into the code, we have quite a different project here. You might see that we are still extending HTML element, but we have also introduced a library called lit. I'll be going more into lit later, but what it does is, in this example, it just helps us re-render and render the content on the page more effectively. So as we can see, the constructor is quite the same. We have the properties, we have a add a shadow, and nothing else. We have a render card method, which looks quite different from previous. You might also notice that there's no template at the top of the file. So earlier we had the template tag at the top of the file, but with lit HTML, we can have a template literal, which contains all of our code that we need. And it's a template literal is a normal JavaScript way of adding code into your strings. And the HTML template literal does a lot of heavy lifting under the surface. I've tried to replicate it, and then I just gave up because it's just so powerful, and I was just it's only 2.6 kilobytes, so what can I lose here? But basically, the render function of the lit HTML library takes a template literal HTML, which contains our page HTML, and it gets a target, which is a shadow root of this component. So we are able to render the content here. And what it does under the surface is it doesn't update anything that isn't necessary to be updated. For example, here we search for a new Pokemon and we call the render card. The render card method gets called. You just have to trust me on this one. But nothing updates on the page because it doesn't have to update anything on the page. So if we go back onto a Pokemon card that does need to update, it does update only the elements that need updating. So here it needs to update the PSYDAC text, and here the base P text, and here the image tag. So it does a lot of functionality for such a small library. And Another part that makes this so powerful is bindings that you might have been introduced to in React, for example. So instead of having to write this.shadow.query selector image, add event listener, click, and doing something, with lit HTML you can just write @click and you give it the callback. So if we just put it into our image element and click on our image element, we have a fully functioning event listener in our image element without any heavy lifting. We don't have to write any more code than this, and it works. Also, if we wanted to have a class function, like you should, so have a function here which is like say foo, console log foo, and we could also log which Pokemon we are currently displaying. If we just put this dot say foo, when we click on the card, we have foo and then undefined. But if we have sideax set here and base p, I think that should work. Well, we have undefined because of demo effect, I think, or something. But it should. Oh, actually, there's a bind this. I think that's what's missing. I misremembered. Lit HTML doesn't give you the binding itself, so you have to still bind the context of this in the callback. You could of course use a arrow function, so you could just do this, and it would just work perfectly. But with the next example, we are going to be having this binding do it for us without our like intervenience. So the last demo we have is the same project, a bit more pumped up. So we have our lit element demo, which has a lot of different things that we have done. Let's see, dev server, and it's running. And we have a Houston, we have a npm install missing. So that's a nice
demo effect.
Yeah, but here you also saw I had npm install missing. I have the whole lit library using in the project, and it downloaded itself in 6 seconds. How many projects do actually npm install in 6 seconds? That's like super fast, and it's solely because the library is just so small. All right, so here we have a similar looking view, and if we look at it in our code editor, we still have our Pokemon card, but this time it extends the lit element class. So lit element is a class shipped by lit, so the same people that did the HTML tag in the previous example. And with lit element, you have a nice base class that has the property binding built in. So we just tell the element which properties we want to bind. So we had the Pokemon, we had the set, we had the large, we have some other properties that we want to react to when they change. So we want to react to them when the state of these properties changes. We can give them typing. In JavaScript, it doesn't really matter, but it does help it out in determining what the type is. And we can also reflect it. The reflection just says, when this property is set, make the attribute match the property. So we have the attributes also synced up with the properties. Here in constructor, we just like give the default values, and we have a updated callback. So in the previous example, we had a attribute change callback. The updated does basically the same, but with superpower. So every time a property changed in our component, we get notified by the updated, and we get a list of changed properties, so we know exactly what changed. And then we can say that, like, if it has a Pokemon, if the Pokemon changed, then we maybe want to update the card. So we can have conditional rendering in the update function. We also have a first updated, which is basically the connected callback, but it launches a little bit later on. So we can also be safe that we are in the document element. We know we can add event listeners now because we have the browser to help us out with that. So we have just attached some event listeners there. You'll see later why. Then we just have the update card, which is basically the same as we had before. And we have a render method. So instead of us having to call the render ourselves, lit element has it built in. So kind of like in React, you return in React hooks, for example, you return the JSX you want to render. In lit element, you put the HTML tag, HTML template literal, and you return it from the return function, render function, and you get everything inside the HTML template literal printed onto your web component. And also we have styles, which just creates encapsulated styles for us, which do not leak into the light DOM. And if we look at it, we can search for Pikachus, for example, and we had another component here called Pokemon Showcase, which just gets all the Pikachu cards, iterates through them, and creates a Pokemon card custom element for each Pokemon we found. So in here we have all the Pikachu cards that we wanted, and we are able to give it a lot of different properties. So you saw the properties in the card class. In the top, there's Pokemon set large card, etc. The same properties we can give to it here. And as you might see, not all of them are attributes. Some of them have a question mark before them. So this is when you have a Boolean attribute, you can bind it into a value. This could be, for example, this dot wants to render, and it could be bound to any value on the page. There's a period before some of the attributes, and that means, okay, this is a property, so this is most likely some more complicated data, for example, a JavaScript object. So we want to give it to you as a object and not as a string, which is what attributes do. And then there's event listeners, just regular Boolean attributes, and some more event listeners. And what it does at the top level is just gets all the Pokemon cards, and well, my streaming PC is not all that fast, but it's able to quite fast modify all the cards when one of the cards is updated. So lit element is really fast at updating the rendering. So when I hover one card, we go through the render function and we give all the other cards a opaque flag. And the opaque flag is set to a CSS attribute. As we can see, let's see. Let's see here. So the opaque flag is just a CSS attribute here. Hold on a minute. Yes, here. So if a Pokemon card has the attribute opaque, we put the opacity as 0.3 here. And it gives you the opaque flag if you don't have the hovered card ID. If your card ID isn't the hovered card ID. So as you can see, it's really fast at updating the DOM, and we can see here if we open the showcase. The laptop is really struggling with this, but it's because we're streaming. But we can see that only the elements' attribute gets changed. So the whole element doesn't get changed. It just gets the attribute added because it's the only thing that needs to be changed, and nothing else. So it's really effective at figuring out what it should be doing and what it should not be modifying. Anybody who has worked with performance on DOM elements knows that any access to the DOM is really expensive. So the less you can access the DOM, the better. And I think I need to give you some time to speak because we're really running out of time, and I'm sorry I couldn't demo more. There's a lot more I would want to demo, but we're running out of time. So I hope this was a nice touch on the surface of web components at least.
Yeah, I think that was really interesting, really exciting. If you want to see more about the tool that Matias is building or his web component stuff, I highly recommend following him on Twitter at Matsu with 3 U's and 1 underscore. nice video that you posted about the tool that you're building. So
Yeah.
really excited to see once you get that launched, and it looks really interesting. And I think that like building those kind of tools is really something that takes the entire thing forward. Both the ecosystem and the tooling, and makes it more accessible for everybody to work on that.
Yeah, for sure. And also, since we had to kind of like fly through the steps, I linked to you, Juhis, in private chat because I don't know how the chat works here. I linked the GitHub repo with all the examples I ran through today, and there's a lot more examples. For example, there's how you would use this in TypeScript, which makes it a lot more cleaner. So there's like a lot more power if you do lit elements with TypeScript. And before we go into closing, if I could shout out a few things people interested in web components should check out. Well, of course, the first one is openvc.org. It's a perfect starting stone for your web component journey. There's also web components from zero to hero. There's a Dev2 article series by a good contact of mine, Pascal Schlipp. I hope I don't butcher that name. There's a perfect series revolving around writing web components. It's a bit dated, but it's still really good information. Also, lit.dev. Lit Element 2.0 just came out not too long ago. It's like still in like the beta phases, but it's one of the most powerful, in my opinion, web component frameworks. Not frameworks, it's just a library. It's not a full-on framework that you can use to build web components. And Lit is about the reason why I got so invested in web components. And it's really small. It's the whole library is tree shakeable and it's under 3 kilobytes. When you compare it to something like React DOM, which is 40 kilobytes. It's of course tree shakeable, but there's still a lot of comparison in size to other popular frameworks. So Lit being just a library, it's able to pack a lot of punch into a small package.
Yeah, you can find links to these in the description. I will add the dev post also to the description after the live stream. If you liked what you saw today, don't hesitate to subscribe in YouTube. There's more coming. In July, I'm gonna take a break. I'm currently on a summer holiday, so I will take a little bit of a break from Codebase. We will return in August. To make sure that you don't miss it, make sure to subscribe. Follow me on Twitter. Check out on my website. And if you feel that this 90 minutes wasn't enough of the front-end developer stuff, our good friends at React Finland are running their podcast starting in 30 minutes at 7 p.m. Eastern European Standard Time. You can find them at reactfinland.fi. I will also link to that in the chat. So if you're watching this live in 30 minutes, couple of really good people doing some cool demos, highly recommend. Or if you think that this was plenty of tech for today, the Euro 2020 football competition is also starting the first match is starting in 30 minutes. Thanks a lot, Matias, for joining. This was awesome. I learned a bunch. I hope that the people in the chat also learned a lot.
Yeah, thanks for having me. Thanks for having me. Yeah, thanks for having me. It was a joy, and I would said it a bunch that I could just go on and on about web components, and I hope that anybody in, for example, Code Clinica who is watching and got interested just shoots me a DM and just sends me a direct message and asks more if they got interested. And as we were running out of time, it kind of got messy, but we got through it, and I hope I sparked at least some interest in all of you in web components, be it with vanilla or lit.
Yeah, that's really the essence of the show, is to give people something they can see different technologies, get excited
Yeah, for sure.
Since there's definitely more deep dive opportunities that we can take a closer look at those.
Yeah, for sure.